And then we need to take our tests. We got an hour and a half, so 140, or whatever it is now. Yeah, 140, yeah. So 140 to whatever that is, 310, we'll take our exam, hour and a half. We'll take exam number 5. So that'll be in 35 minutes. All right, so let's see what we can get done in those 35 minutes. So how do we solve something like this? X squared plus y squared is 109, x times y equals 30. So what are we doing in this section? Yeah, start with, so remember, yeah, we always start with the easier one. Good job, good memory. Start with the easier. Which one looks easier?
The bottom one.
Probably that bottom one, huh?
Yeah.
So grab that bottom one. So x times y equals 30. What do I do with that bottom one? Yeah, just get either x or y alone, plug into the other one. Getting the hang of this, how this whole thing works? All right, so divide by x, let's say, or y, it doesn't really matter. So y equals 30 over x. So now, so you get either x or y alone in the easier equation, then you plug that into the other equation. So y equals 30 over x, plug that into the other one. So the other one is x squared plus y squared is 109. So plug that in right there. X squared plus 30 over x squared is 109. Good. Bring it up here. So that's x squared. Am I going too quick? We good so far? So just get x or y alone in the easier equation, plug into the harder equation. And now you only have one letter, so you can solve. Now, how do you square? What do you do this part right here? Square 30 over x. You just square the 30, square the x. You can use your calculator. It just means, 30 times 30, which is 900. And x times x, which is x squared. Is that good so far? I just squared the 30, squared the x. Now, how do we solve equations that have fractions in them? Well, that's just if they only have one fraction on each side. This has 3 things, so we have to multiply through by the denominator, right? Don't we just multiply through by the denominator when we got fractions? Everybody? What's that? Cross multiply is where we just have one fraction on each side. You with me? Like if I didn't have this x squared here, I would cross multiply. So let me address that since a couple people have said that. Right? If you just have one thing on each side, that's when you cross multiply. Excuse me. But if you have 3 items, see how we have 3 items? 1, 2, 3 things. You can't just cross multiply. We got 3 things. So we have to multiply through by x squared, x squared, x squared, everybody, right? These ones cancel in the middle. In the front, x squared times x squared, x to the 4th. In the middle, 900. At the back, 109x squared. How we doing? Now what? Yeah, get a 0 because you got these higher power things. You just want to get a 0, huh? So jump this 109x squared. Let's put them in the middle. Remember how we put them in order, highest power to lowest, so that 109x squared will go in the middle. So x to the 4th minus 109x squared plus 900 equals 0.
We can do the u equation on this, can't we?
Yeah, you're right. You could do the u thing. Or you could just kind of factor it straight. Do you know what I mean? You could just say, look, x squared will multiply to be x to the 4th. And then what multiplies to be 900? I don't know. They can make 109 in the middle? I don't know.
Should we throw it in the fun?
We could. I'd rather not do that if we could avoid it.
-9 times 100.
Did you find it that quick? Oh, yeah. Yeah, good job, Julio. Yeah. Yeah. So, so just take the 900. Remember how it works. Remember when you're trying to say, okay, look, I'm trying to find 2 numbers that multiply to be 900. Add to be 109. Remember what you do is you just try dividing by different things. Do you remember that? Am I confusing you here? Is that good? So you just take the 900 and you just start dividing by different things. Well, Julio just mentioned if you divide by 100, you get 9. You go, oh yeah, those two, they make 109, huh? That was a good observation. So yeah, if you can't find it, you could put those in the quadratic formula. You know, the negative b plus or minus, that whole thing. But that's kind of a pain. So this is better. So minus 9 minus 100. Does that make sense? Because the two negatives multiply to be positive, 900, and they add to be negative 109.
Those are difference of squares too.
Right. So we good to there. Everybody good to there. So what I'm going to do now is I'm going to, when two things times to be 0, remember what you do, each one is 0. So, and then, so really it's just going to be x squared is 9, x squared is 100, right? You know how it just ends up being opposite sign, opposite sign. But that's x squared, notice, not x.
Root it?
So just root it. Yeah, exactly. And what happens whenever we root something?
Makes it bigger or not.
Plus or minus, huh? When you put a roof on the house, up and down the ladder. I got a saying for everything in math. Up and down the ladder, plus and minus. Plus and minus 3, and then same thing over here, root it, plus or minus. X is plus or minus 10, huh? Plus or minus 3, plus or minus 10. 4 x answers. 4 x answers. We still got to get y, but is everybody okay to there? See how that worked? Are we happy about that? So it's not an easy one for sure. So I solve for x, or I guess I solve for y, huh? In the easier equation, plugged into the main one, got the fractions, multiplied through by x squared, got an x to the 4th, so I got a 0, factored it, using the calculator there. Then square root, the x squared is 9, x squared is 100, root it, plus or minus 3, plus or minus 10. Okay, so now, we have x is plus or minus 3, and x is plus or minus 10, right? 10, yeah. Okay, so we have to, for each of these answers, we have to find a y value that goes with each of them. In fact, why don't I break these into two separate here? Plus 3, and then minus 3, and then plus 10, and minus 10. Why don't we do that? Okay, so for each of these, we've got to plug in. What are we going to plug? What do we need to find? Y. So let's look back over here. What would be the easiest place to plug in if you want y?
The second one?
Yeah, I kind of erased it here. Right here, y is already alone. I kind of erased it. It was down here. 30 over x. Yeah, it's easiest to go where y is already alone since you want y. Does that make sense? You getting the hang of that? I've done that every time on these. Whenever I go to get my second letter, like I have x and I want y or vice versa, when you have one answer and you want the other, if you're looking for y, just go back to some place you had y alone. There almost always will be a place you had that alone. That'll be the easiest thing to work with. So I'll do that. I had y alone. I already forgot what it is. 30 over x. So y is 30. So in all these, I'm going to plug in to 30 over x. Y is 30 over x. So plug in the 3, plug in the negative 3, plug in the 10, plug in the minus 10 there. So what do we got? 30 over 3, 10. So that means that's the answer 3, 10. Everybody see how I got that? The x equals 3 led to the y10. Next one, plug in the negative 3. 30 over negative 3, so that's negative 10, huh? So that's negative 3 led to negative 10. Negative 3 for x, negative 10 for y. They go together, right? It's like, I think I made the analogy of descendants, right? Parents lead to children. They're related. They're connected. So plug in the 10 here. 30 over 10, y is 3. So that's the answer, 10, 3. And last one, plug in the negative 10, y is negative 3. So that's the answer, negative 10, negative 3. There they are. Bless you. Questions on that one? Are we okay? Just a lot of work on these, aren't there? Aren't they? They take a long time. Is it all good? All right. I'm going to move off if you're okay. Okay. I'll write it up here. So we have 3xy plus 4y squared is 16. 4xy minus 3y squared is 13. Notice on this one, those are like terms. Do you see what I mean? These two are both, like terms mean same letter pattern. Those are 3xy, 4xy, same letter pattern, huh? These two, they're like. They're both just y squared letter patterns. So when they're like terms, I can do what method?
You can, yeah, substitution.
Substitution would be hard on this one. You could do substitution. You're going to get fractions, a lot of fractions. Want me to show you? Don't write this down. Let me show you what I mean. Don't write this down. If I wanted to do substitution, what would I solve for example? Which one's easier? Neither one. They're the same. That's the point. They're equal, complex, right? Neither one's easier. But it's okay. So grab the top one. Say, okay, I'm going to take the top one. Don't write this down. This is not going to work. I just want to show you how ugly it'll get. Why you don't want to use substitution on this one. I'm going to use the addition method instead. I'm going to multiply. I'm going to make these both 12. One of them a positive 12, one of them a negative 12. Add them up. Bye-bye xy term. I'm going to do that method instead. Just a minute, I'll do that. Let me show you why you don't want to do substitution. Do you see how this is fundamentally different from the last one? Look at the last one. See these guys? Those are not like terms. This is x squared. This is xy. That's different. This is y squared. Again, that's just xy. That's different. Not like terms. So if they're not like terms, yeah, you can't add them up. You can't add non-like terms. They won't add, right? They won't come together. So you had to do substitution. We had no choice. All the other ones we've done up to now had to do substitution. But on this one, these guys are like terms. So we can add them and subtract them. We can do the addition method. Remember that where you make the front two opposites, you add them up and they cancel? We'll do that kind of thing. Now, why? Why don't we just do substitution anyway? Because it'd be terrible. Let me show you. What do you want to solve for here? X, Y. It'd be terrible either way. So if you move, say you think, okay, I'll solve for x. Okay, move that over. Get 16 minus 4y squared. How you gonna solve for x now? Divide by 3y. Okay, there's x. You want to plug that in?
No.
Want to plug that in like there? Not nice at all. Awful. Right? No. Don't do that. No substitution. No substitution on this one. It'd be terrible, however you spell that. Instead, we're going to do the addition method. So let's go back, let's restart, and let's do the addition method. So 3xy plus 4y squared is 16. 4xy minus 3y squared is 13. So like terms, when they're like terms, in other words, there's not one equation that's easier. They're same, aren't they? They both are xy, y squared, xy, y squared. They're like terms. When you do that, do the addition method, or it's called elimination also, whichever name you want to call it by. In other words, make opposites. Remember that method? We had that? I think that was like the first week of class or something. It's been a long time. But we did it a couple times. I think you're probably pretty good at it. So I'm going to make the fronts both become 12. One of them a negative 12, one of them a positive 12. Remember how that works? So I'll multiply through the top equation by like negative 4, boom, 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 and the bottom equation by positive 3, boom, boom, boom. See, that'll do it. So that'll be negative 12xy, negative 16y squared, negative 64. The bottom one will become 12xy minus 9y squared is 39. Then add them up. Bye-bye to that term. Remember all that kind of thing where you make the fronts opposite so they'll cancel out? The only reason we're allowed to do this is because these are like terms. If this was like xy and this was like y squared, well, you can't add them or subtract them. They'd be unlike. They can't combine. But when they're like terms, you can do this. This is way easier. So is this minus 25y squared? This is something I don't know. Minus 25? Oh, that's convenient. Yeah, that's what it is. Okay, so divide by minus 25. Y squared is 1. Am I racing ahead of you? You with me? Get that again. Y squared is 1. What do we do there? Root it, plus or minus. We're going to put a roof on the house. Go up and down that ladder. Plus or minus 1. So we get y equals plus or minus 1. plus or minus 1. So we got y, now it's time to go get x. Where do you go? Plug in anywhere you want. Go back to the original, plug them in. So there might be room over here. Let me see if I have room. Get rid of that plus sign there. So I'm going to plug in y is plus 1 first off. Where you plug it in? I'll just grab the first equation. You can do the first, second, doesn't matter at all. Either one. Because neither one's easier, right? They're equal level. They're like terms. So plug in the positive 1 in both spots, both places you have y. 3x times 1 plus 4 times 1 squared equals 16. And that's going to be 3x plus 4 is 16. Subtract 4. 3x is 12. Divide by 3. X is 4. Good there? So I got x equals 4. Who did he come from? Y equals 1. Right? Remember who they're related to, connected to. So that's the answer 4, 1, x, y. And then we also have to do the y negative 1. Remember, because this was plus or minus 1. We have to do both separately. Which is a pain, which makes these problems go on and on and on forever, don't we? So now I've got to do the negative 1. Okay, if I just like scribble it up here. Get all this out of the way. Okay. So here we go. So now y equals negative 1. Plug it in. Into what? Again, I'll just grab the first. You do the second. Doesn't matter. Whichever equation. Whatever. Same thing. Same answer. So plug in negative 1. Plug in negative 1. Get 3x times negative 1 plus 4 times negative 1 squared is 16. That's negative 3x plus 4 is 16. Bless you. Subtract 4 from both sides. We're going to hear negative 3x is 12. Divide by negative 3. X is negative 4. Going with y negative 1. There it is. We got our two answers. So what are the two answers in the end? Negative 4, negative 1. That's x, y. And then this answer here is 4, 1. Again, x, y. There's our two answers. They're both 4, 1. Both negative or both positive. Is that okay? That makes sense? So when do we do the addition method instead of substitution? Like terms. Like terms. Everybody seeing that? They have like terms. So you always want to look at them at first and say, are they like terms or not? If they're like terms, do the addition method. If they're not, do the substitution. Let me write that down. So for whenever you have two equations, so what we're talking about here, when you have two equations, number one, if they're like terms, which means same letter pattern, then do the addition method. Do the addition method. Make the fronts opposites. Right? Otherwise, if they're not like terms, do the substitution method where you plug one into the other. So that's how we handle two equations. We look at them right away and say, are they like terms? And so I'm going to do the addition method, make the fronts opposites, and add them up. Otherwise, I'm going to do the substitution method, right, which always means A, solve for X or Y in the easier, B, plug into the harder. Solve for X or Y in the easier, plug into the harder. So those are the two methods for this difficult section. All right, good, bless you. Well, have we all got our winter colds?
No, I'm not sick.
It's just starting to feel like fall. I don't know if it's winter yet, huh?
What day is our final going to be?
I don't know. It's on the syllabus. I think it's Monday or something. Is it Monday?
It's
Yeah,
on the
Monday of finals week. 10ab. Okay, so what do you think about that one? How should we do that one? Are they like terms or are they not like terms?
They're like terms.
Yeah, they're most clearly like terms. Same letter patterns, huh? So can you solve that one? So what's the first step up there? Make those fronts opposites. And they really are already the same, so you just got to make one of them negative, huh? Just multiply the top equation or the bottom, doesn't matter which one, by -1, right? Does that make sense? Multiply one of those equations by -1, and then the fronts will be opposites. So maybe I'll just do the top equation. Doesn't matter, top or bottom, whatever. Boom, boom, boom. So we get -ab plus b squared plus 10. The bottom one I'll just bring down, no changes. ab minus 2b squared minus 15. Add them up, boom, those cancel. Good so far? b squared, that's really 1b squared, huh? 1b squared minus 2b squared?
Negative 1.
-1b squared. And then 10 minus 15 is -5. The ab's have dropped out. Divide by the -1 first. So b squared is 5. And what do? Root it, plus or minus. Put a roof in the house, up and down the ladder. Root, plus or minus, so b is plus or minus root 5. Then I'm just going to go dot, dot, dot. I want to do something else with our class time than just say. Now you just plug in the plus root 5, the minus root 5, find the a that goes with each one, and finish it up. Am I good? Is all well? Questions I can answer? Equations, I don't think. All right, Computer Parts Company wants to make a rectangular memory board that's a perimeter 14, diagonal length 5. What are the dimensions of the board? Okay, yeah, so if you have a rectangle, and you have like a width and a length, and a width here and a length here, and then a diagonal. Yeah, everywhere, width. Okay, so now they're talking about perimeter. What's the perimeter formula for a rectangle?
Side, plus side, plus side.
Yeah, perimeter means all the way around the outer edge, right? So like if you start here, for example, you go length, and width again, so it's 2 lengths plus 2 widths. Remember that perimeter formula? How we doing? Good so far? 2 lengths and 2 widths? All right, and then the diagonal is 5. So this diagonal right here is 5. So the perimeter is 14. I can grab a 14 and put it right in here. This is 14 equals 2 length plus 2 width, because the perimeter is 14. The diagonal, what am I going to do with the diagonal? Notice I have 2 letters, so I need 2 equations. So I need one more equation, don't I? Whenever you have 2 letters, you need 2 equations to solve them. So I need one more equation. What other equation can I do using the diagonal? Yeah, Pythagorean, a squared plus b squared is c squared, right? There's a right triangle here, right? Right angle, rectangle, has right angles. So that means L squared plus W squared is 5 squared. Remember A squared plus B squared is C squared? There's our 2 equations. So one of them is 14 is 2L plus 2W, and one of them is L squared plus W squared is 5 squared, 25. You can just make this 25 right now. So there we have 2 equations with 2 letters. So we can solve them, maybe. So here, let me rewrite them. Let me put the 14 on the right side here, so they're a little easier to deal with. So L squared plus W squared is 25, and 2L plus 2W is 14. Let's kind of line them up like that. So there's our two equations. Is that good? Everybody see how I found those? This is the perimeter one. 2 lengths and 2 widths is 14. This is the Pythagorean. A squared plus B squared is diagonal squared, right? This triangle. I'm just doing that triangle right there. Okay, now, how am I going to solve those? Are they like terms? Remember, that's what you wanted. Now it's solving time. We're done with the words. Forget about the words. Just words are over, whatever. Now I'm just focused on these equations. And so I want to ask myself, are those like terms? No. L squared and regular L. Not the same letter pattern. Not like. They're not like. So what am I going to do? Substitution method. What does that mean, substitution method? So take the easier equation. Which one of those is easier? Yeah, the bottom one, because it doesn't have powers. It doesn't have as many powers, right? Or any powers. So 2L plus 2W. Take the bottom one, and what do you do?
Solve for one of them.
Solve for L or W, doesn't really matter. Yeah, exactly. So jump the W over here. So we'll get 2L is 14 minus 2W. Good so far. Then divide through by 2. Divide them all by 2. And I get L equals, what's that, 7 minus W? See what I got there? And then what do we do with that? Plug that in. Plug this in to where? The harder one, right? Because you start with the easier one, and then you plug it into the harder one. So plug that in right there, and I don't feel like doing any more of this problem. All right? I want to set up the other ones for you. We only got 6 minutes. Yeah. So I'd rather use those 6 minutes showing you how to set up the other words. I think it's better use of our time. But you know the rest. We've done 5 of them yesterday, right? Or Monday. Right? You just plug into here and work it all out.
Are those notes on YouTube? Yeah.
Yeah, I think so.
Okay.
Yeah. There your rectangle has an area 1989 square inches and a perimeter 180. Find this much. So let me try to link L and W, length and width. You want 2 equations. One of them is for area, one of them is for perimeter. This is for a rectangle. So what's the area formula? What's the area of a rectangle? Length times width? Right? You guys know that one, right? Let me just draw a rectangle real quick. Make sure. Right? See, if you have a rectangle that's got like 1, 2, 3 rows high, and it's 1, 2, 3, 4. How many total squares in the middle? If I say, hey, there's 3 rows of 4, how many total little squares do we have here? 12, huh? You just multiply one side times the other, huh? That makes sense? That's where area comes from, right? There's 12 here, and 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you just multiply 3 by 4, just 3 times 4. That's where the area formula comes from. You want to know the space in the middle of a rectangle, you just do one side times the other, don't you? And that gives you everything in the middle of the rectangle. And it's actually squares, isn't it? It's how many squares. That's why they put it in square units. Just like the floor. Look at the floor. Those are square feet. Right? So how many... Well, I don't know if you can see it in the gray very well. Yeah, you can see it a little bit. Those are square feet. How many square feet fill up the whole area? How many square inches? Okay, so there's area. So 1989 is the area. So that'd be 1989 is L times W, length times width. And then... what's the perimeter formula? We just did that one, right? 2L plus 2W is 180. That's outer edge, because that's length, width, 2 lengths and 2 widths added up. There's our 2 formulas. Is that good? Those are our 2 formulas? So, are we going to do the addition method or the substitution method? Yeah, are these like terms? No, L times W is a different kind of animal than L added to W. They're different. So, I'm going to go dot, dot, dot. You just use sub. Use the sub method. Solve for L or W in one equation, plug into the other. Good? Let's keep going. I want to set up the last two word problems for you. Homework. And we'll be done. All right. The diagonal of a rectangle is 2 feet longer than the length and 5 feet longer than twice the width. What?
What?
It's kind of weird, huh? I don't remember this one. It's like I know all these problems. Let's just give it a try, see what happens. Here we go. Diagonal. So I'm going to draw a rectangle. When I don't know what's going on, I draw a picture. Diagonal of a rectangle. There's the diagonal. Is 2 feet longer than the length. So I'll just say, okay, here's the length, and this is L plus 2. 2 longer. Good so far? Isn't that what it's saying? I'm just doing what it says. The diagonal is 2 longer than the length. And 5 longer than twice the width. So if this is the width, it's 5 longer, 5 added to twice the width. You good? So in other words, they're telling me how long this diagonal is here. 2 different ways. They're saying, hey, it's L plus 2, or hey, it's 2W plus 5. So then those two things must be equal, because they're both the diagonal. Right? They're just 2 different ways of saying the diagonal. Kind of weird. I don't remember this one.
Get a measuring tape and measure it.
We good to that? Those have to be equal, because they're 2 different ways of saying the diagonal. And then, now, there's 2 letters, so what do you need? 2 equations, 2 equal relationships. So what's my other one? What's this make you think of? Pythagorean. A squared plus B squared is C squared. L squared plus W squared equals... Now, which one of these should we use? Either one. Which one looks easier? L plus 2 looks easier to me. L plus 2 squared. There are 2 equations with 2 letters. Dot, dot, dot. Easy for me to say dot, dot, dot. Are those like terms?
No.
Top equation, bottom? No, they're different, huh? Which one's easier? Top one or bottom one? Easier. This one's easier because it just has regular L, regular W, no powers. So use substitution. Take the top one, the easier one, plug into the bottom. Man, I'm going to run out of time even at that. Let's do it and be done. All right. The ratio of the length. Of the length to the height. So that's L over H, right? That's a ratio of length to height. Is 4 to 3. Equals. Equals is. Is equals. Good for my first equation? The ratio of length to height is 4 to 3. So there's one equation, 2 letters though, so I need one more equation, don't I? Here comes the other one. 43 centimeter diagonal. So that means if you draw the rectangular screen, put the diagonal, they're saying it's 43. This is the width, this is the length. What's my other equation? Yep, Pythagorean. L squared plus W squared is 43 squared. For this equation, you go diagonal, diagonal. 3L is 4H. There's your 2 equations. Dot, dot, dot. This one's easier. Solve for X or Y. L or H. Plug into the other one. Substitution. Away you go. All right. There we go.